So the first thing we look at is marginals. We have marginal cost, marginal revenue, and marginal profit. So if a company wants to make a change, they need to know some data to know if that change is going to be good or not. And a lot of times they can use marginals to approximate that change. So to get a picture of what we're talking about, suppose that we have some animal rescue organization, and currently they're doing 12 public service announcements, but they're thinking about switching to 13. So they're increasing the number per month. So they want to know how much extra this is going to cost them to do 13 instead of 12 PSAs. So what they do is find the rate at which the cost is increasing when 12 PSAs are produced, and then take that rate and add it to the cost of producing 12. And so that's the way they approximate the cost of 13. So they're saying the cost of 13 will just be the cost of 12 plus the rate at which cost is increasing when we have 12 PSAs, or the derivative of the cost function at 12. So the derivative of the cost function at 12 is called the marginal cost at 12. So the marginals is just the derivative, but it's just the derivative when we're using it in this context of approximating the cost of the next so many units. So C prime of 12, the marginal cost at 12, is the approximate cost of the 13th PSA. And so then we add that to the total cost of making 12 PSAs, and that will give us the total cost of 13 PSAs. But the marginal cost at 12 approximates the cost of just the 13th item by itself. So we can represent this idea on this graph. And the bluish line, that's going to be the tangent line of the cost function at 12. And so basically we're using that tangent line to approximate the cost of producing 13 items. Then the red line is the actual cost function. And so you can see the actual cost of 13 items in this case is a little bit less than our approximated or predicted cost. So when we're using marginals, it's not perfect. We are approximating the actual cost or whatever the case might be. But the reason we use marginals is because a lot of times we don't have the actual cost function, so a lot of times we don't know exactly what the cost would be, so we can use these marginals to approximate. So now let's talk about the marginal cost, marginal revenue, and marginal profit. So say we have X items, and then we're interested in the cost, revenue, or profit for the X plus 1 item. So then we can approximate, say, the cost of the X plus 1 item by the cost of X plus the marginal at X. And that same thing works for the revenue and for the profit. So the marginal revenue, cost, or profit is just, say for instance, the marginal profit is just the profit function, the derivative of the profit function at the value of X, and it gives us the approximate profit for the X plus 1 item. So that would be the approximate profit for just the X plus 1 item. But then you can add to that the profit from the X items, and then that will give you the approximate total profit if we sell X plus 1 items. So when we write this equation, this gives us the total profit from selling X plus 1 items, and we can approximate that by taking the profit from selling X items plus the profit from selling the X plus 1 item. So this is the marginal. And so we add the marginal to the profit from selling X items to get to approximate the total profit from selling X plus 1 items. And so then the marginal is just the profit from selling that one item, from selling that one last item that we're talking about. Okay, so let's do an example. We're given the cost, a random cost function and a revenue function, and then first they ask us to find the total profit function. Well, finding the total profit function will be easy for us in this case because we know the total profit is just the revenue function minus the cost function. So we can just plug those two functions in and then subtract. And so to subtract these two functions, of course, we'll need to distribute this negative sign, and we'll get this for our profit function. Now in part B, we want to find the total cost, revenue, and profit from selling 50 units. So we just need to plug 50 into each of these functions. And so I plug 50 into each of my functions, and I get the cost, the revenue, and the profit when we sell 50 items. Now notice that the profit is negative. So in this case, we're losing money if we're selling 50 items, which obviously is not good. Now in part C, we want to find the marginal cost, revenue, and profit when 50 units are produced and sold. So we need to find the derivative of the cost function, profit, and revenue functions, and then we can just evaluate each of those derivatives at 50. So first of all, C prime of x equals 124 times x. So now we plug in 50. So we get 6,200. So this represents the approximate cost of producing the 51st item. Now we find the derivative of the revenue function, and now let's plug in x equals 50, and we get 6,340, which represents the approximate revenue from the 51st item. Now let's find the derivative of the profit function, and then we plug into that function x equals 50, which gives us $140, so that's the approximate profit from the 51st item. So these are all of our marginals for the cost, revenue, and profit. Now notice that the profit from the 51st item is positive, so the 51st item makes us money. So that makes us think if we keep selling more items, we'll probably start to turn a general profit. Now, if you want to use the marginal to approximate the profit of selling 51 items, then we can use this formula. And so that will tell us the approximate profit from selling a total of 51 items. Now, it's still going to be negative because when we sell 50 items, our profit was negative 85,000. We made $140 from selling one more item, from selling that 51st item. But that's not going to be enough to make us go positive. But we can still calculate it. And we get negative 85,350. So we're still in the hole, we're still not making money, but at least we're less in debt now than we were when we sold 50 items. That's the approximate profit using our marginals to approximate it. We could, since in this case we do have the actual profit function, we could calculate the actual profit from selling a total of 51 items. To do that, to find the actual number, we just take 51 and plug it into our profit function. And so we get negative 85,273. So that's the real, or the actual profit from selling 51 items. And this number was the approximate profit that we used the marginal to approximate. So you can see that the two numbers are pretty close to each other, but they're a little bit different. So the marginals won't approximate something perfectly, but it does give us a pretty close estimate when we don't have enough information to find the real number. So in this case, we had both functions, so we were able to compute the real number and the approximate number, but most of the time we don't have the real function, so we just have to approximate it using the marginals. Now just note that marginal cost is different from average cost, or profit, or revenue. So the average cost is for 50 units would just be the cost function of 50 divided by 50. When you do that for this example, you would get $3,650 per unit. So that's the average cost per unit when you produce or sell 50 units. Then the marginal cost when 50 units are produced would just be the derivative evaluated at 50, and we got 6,200. So that's the cost of the 51st unit. So see the difference between the marginal cost and the average cost. So the average cost is just the total cost averaged out over the number of units you're producing. The marginal cost is the cost of a specific unit. Specifically the 51st unit, it itself costs $6,200.